And here's our third example of solving equations with trig functions of arguments besides just x, theta, etc. In the previous examples, we got this down to a simple linear trig function, but we had to do a substitution because our argument was more than x. And this one, we're going to take a slightly different path. We're going to solve cosine of 2x equals cosine of x over one period, 0 to 2 pi, and of course the general solutions. So let's start by figuring out how to attack this problem. Our biggest obstacle right now is the fact that our arguments don't match. Can we fix that? Because if we want to get this down to a point where it's solvable, we need all the arguments to be the same. Now right now one argument is 2x and the other one is x. What do you think would be easier? To rewrite the left so that it has x's instead of 2x's, or rewrite the right so that it has 2x instead of x? And the answer, of course, is to rewrite the left so that it has x instead of 2x, because we have a double angle formula. In fact, we have 3 double angle formulas that allow us to rewrite cosine of 2x. Let's think about what our best option is. The 3 double angle formulas for cosine of 2x are cosine squared x minus sine squared x, 2 cosine squared x minus 1, and 1 minus 2 sine squared x. Which of those 3 do you think would be the best option to put into this equation on the left side? If you said the middle one, you would be correct. The top one would not be good because it would bring in this sign, and now we have different trig functions, and for the same reason the bottom one would not be good. The middle one, however, would bring in cosine of x, which we already have. So we're going to replace cosine of 2x with 2 cosine squared x minus 1 equal cosine of x. And now we have a basic quadratic trig equation in cosine. So we get it equal to 0 and we'll proceed. Let's leave the cosine squared on the left because it's already positive. So we'll bring the cosine from the right to the left, which will make it negative. And of course the minus 1. Now at this point you can try to factor, you can try to use the quadratic formula. I myself am not scared of factoring. Actually, if I follow the protocol that I laid out before, we should probably do a substitution here. It's not 100% essential. It can be bypassed for the sake of consistency. Let's let cosine of x equal to u. That would give us 2u squared minus u minus 1 is equal to 0. This will factor, and honestly it would factor up here as well. If you're comfortable factoring with the trig function inside, then by all means you don't have to do the substitution. But if your factoring skills feel like they're going to be impeded by the presence of the trig function, then take the trig function out with the substitution. Let's see, we need a minus in the middle, so it's probably going to be this. Let's just FOIL it real quick. 2u times u is u squared, good. Positive 1 times negative 1 is negative 1, that's good. Now I get to check the middle. That's negative 2u, that's positive 1u. Negative 2 plus 1 is negative 1. It is the correct factorization. And since it's factored in equal to 0, we can set each part equal to 0. And then solve, we get u equals negative 1/2 and u equals 1. However, substitutions in this case are temporary because the u is representing cosine of x. So we're going to put the cosine of x back in. Cosine of x equals negative 1/2. Cosine of x is equal to 1. Let's solve this one first. 1 is a value of the cosine on a quadrantial angle. And remember that on the unit circle, the cosine is the x-coordinate. And the only place on the unit circle with the x-coordinate is 1 is over here. And that corresponds to 0 radians, or 2 pi, but we're not including 2 pi in the interval. And as far as the negative 1/2, because cosine is negative, we would not want quadrants 1 or 4, so we're looking at quadrants 2 and 3. And our reference angle is going to be inverse cosine of the absolute value 1/2, which I believe is pi over 3. Pi over 3. So we need to place pi over 3 in quadrants 2 and 3 and measure them. If we put pi over 3 as a reference angle in quadrant 2 and measure it from standard position, then our x is going to be pi minus pi over 3. So x would be 2 pi over 3. And if we put a reference angle of pi over 3 in quadrant 3, and then measure it from standard position, then our x will be pi plus pi over 3. So x is 4 pi over 3. So here are our specific solutions in the desired interval. And for our general solutions, we just have to append the multiplier, the period multiplier. So our general solutions will be x equals 2 pi over 3 plus 2 pi n, 4 pi over 3 plus 2 pi n. And technically 0 plus 2 pi n, but 0 plus anything is itself, so we don't need the 0. And of course, all of these are an element of the equation.